I'm now going to do number 70 on page 519. Again, I don't have my calculator with me. Bear with me, but I should be able to talk you through it all. Trace metals found in wells affect the taste of drinking water, and the high concentration can pose a health risk. Researchers measured the concentration of zinc in milligrams per liter near the top and bottom of 10 randomly selected wells in a large region. The data are provided in the table below. Construct and interpret a 95% confidence interval for the mean difference of mu in zinc concentrations from these two locations in the wells. This is exactly like number 10 on the Schoology quiz, which I discussed today. There's some setup involved in this. You can either do it in your calculator, okay, or you can do it by hand, but either way, something needs to go in your calculator. In L1, what I would do is I would put the bottom. If you're looking at the problem, they give you the bottom in that table. In L2, I would put the top. And then in L3, I would go up there and I would enter L1 minus L2, or vice versa. Okay, and again, I don't have my calculator, so I'm trying to explain it based off the answer in the book and kind of talk you through it. I would pause the video right now and do that. Once you do that, then you need to run a one variable stats on L3, okay? From that one variable stats, you need to get X bar, you need to get SX. Do not get sigma X. It's not okay. When you get X bar, you should get something to the effect of 0.0804. SX, you should get 0.0523. Moving on to the next page, we're now ready to begin the actual problem. So we're going to check our conditions. We could do the state. I'm sorry, I didn't do that. If we did the state step, the state says we want a 95% confidence interval for the mean difference. It's just restating the question. The conditions run random. It is stated. Independence, 10 times 10 has to be less than or equal to capital, or just less than, excuse me. Capital N is all the different spots in the well. N, this is reasonable. N is equal to your normal distribution. Now you have to ask, do I do the NP, N times P, and the N times 1 minus P is greater than or equal to 10? Or do I try to use that central limit theorem? Since we're dealing with averages, quantitative data, we say N is greater than or equal to 30. So we only have 10, so we're in trouble. So what we need to do right now is we need to graph L3. Now listen carefully. As long as there is no strong skew, you can graph it, sketch it, and say it's symmetric enough to proceed. We then need to name the method. Lots of you were forgetting this step. The method is a one sample T interval, whoopsie, for mu. Next, we need to do our state plan do step. Okay, we need our side work when we're dealing with the T distribution. So our X bar was 0.0804. Our standard deviation is equal to 0.0523. Our degrees of freedom are equal to 10 minus 1, which is equal to 9. Our n is equal to 10. And then our T star for a 95% confidence interval with 9 degrees of freedom is equal to 2.262. We are now ready to find our lower bound and our upper bound. Our lower bound would be 0.0804 minus 2.262 times your standard deviation. I don't have room, so Sx divided by the square root of 10. Your upper bound would be 0.0804 plus 2.262 times the standard deviation, and again, I don't have room, times the square root of 10. You then get an interval going from 0.043 to 0.1178. The state, plan is your conditions on your method, your do, now your conclude. We are 95% confident that the interval from 0.043 to 0.1178 captures the true average difference in the amount of zinc between the bottom and top of the well. Finally, Part B says, does your interval in Part A give convincing evidence of a difference in zinc concentrations at the top and bottom of wells in the region? Justify your answer. Well, the easiest way to justify this is if there was no difference, if there was a chance of no difference, 0 would be in the interval. That means it could be 0, it could be something above it or below it, but if 0 is in the interval, there is a chance that that's the truth. 0 is not in the interval. So we have strong evidence the truth is in the interval, which there is a difference then. All right, 8 minutes later and I'm done.